Ladies and gentlemen, thank you for my time. Let me introduce myself. My name is Chendri Tasoid. I want to present my journal. The title of journal is The Effect of Transcontaminants on Gluten-free Soy Bread Bags Using Organic Heating. Why we develop gluten-free bread? Because there are various studies have been conducted on gluten-free bread development due to the increase in gluten-intolerant customer demand. The target of gluten-free bread is the individual who suffers from celiac disease, attains the healthy trend lifestyle that developed in public. The gluten-free bread in public commercially has advantages. The gluten-free bread produced still has some drawbacks and limitations, such as the bread volume development that did not live up to expectation, weak structure, crumb, and organoleptic aspect which much different from wheat-based product. The previous work is to compare the quality of gluten-free bread made from black soybean flour using and without using transglutaminase that was baked using ohmic heating technology. Besides that, the change of process parameter including temperature change, electrical conductivity, current intensity, and electrical power of transglutaminase with addition will be analyzed during the process which is presented for unit time. The use of transglutaminase in the making of gluten-free bread is known to enhance the better rheology aspect and increase the bread quality produced. The last step is baking with ohmic heating. The next methodology, the first step is preparation ingredients. After that, the perform is proofing, and then the last step is baking with ohmic heating. Result. Picture one, we see effect of transcontamination addition on appearance and structure of bread pores. Table 1 from the result of expansion volume, pore count, area, porosity were obtained in bread with addition of transglutaminase and were strongly correlated with the smaller average pore size found in bread with the addition of transglutaminase. Still on table 1, the texture is a parameter that is closely related to how easily a food is chewed in the mouth, and its value was determined by the calculation of some texture parameters, including hardness, springiness, chewiness, residence, and cohesiveness. The result of the table 1 show that lower hardness values were produced in bread with the addition of transglutaminase. The binding of hardness value in this breed was highly correlated with volume expansion, as well as the higher cohesiveness value, which was found to be higher than control. The color of the crumb on bread without the addition of transglutaminase had a higher or brightness, and B or yellow on bread without the addition of transglutaminase, because the ohmic heating process can only reach a temperature of 100 degrees Celsius. A Maillard reaction can occur. So the color change is thought occur due to the impact of starch glutinization reaction and protein denaturation during the baking process. Result 2. Core temperature change in gluten-free bread during the baking process using ohmic heating that measured by 3 thermocouples near electroda. Overall, the addition of the transglutaminase enzyme can greatly affect the baking temperature This is indicated by uniformity of temperature rise and the longer duration of the high temperature compared to the breed without the addition of transcontamination enzyme. Porositas properties of the breed can increase the rate of electrical conductivity, which has an impact to the heating temperature. Transcontamination can modify the proteins by combining amines and altering the intermolecular coupling of the mediation, which cause the basic change in their molecular structure. The picture 3 current intensity change during the baking process using of heating or black line without transcontamination and with transcontaminase. The picture or figure for electrical power change during the baking process using only heating without transcontaminase and with transcontaminase. The, the increase in electrical conductivity in baking process of gluten-free bread whether increase with the increment in the temperature. Figure 5 electrical conductivity change of gluten-free bread during the baking process using only heating without transcontaminase and with transcontaminase. And figure or picture 6 variation of electrical conductivity versus temperature during the baking process using ohmic heating without transcontaminase and with transcontaminase. In the baking process, the power current requirement during the process is very important for energy, times, and cost efficiency. The change in the electrical conductivity is linear with the increase of current intensity and then electrical power use. Conclusion. Overall, the addition of transcontaminase has a significant effect on the baking process of soy-based gluten-free bread using ohmic heating. It is shown that soy-based gluten-free bread produced with the addition of transcontaminase has better quality in parameter specific volume, texture, and color than without the addition of transcontaminase. On the other hand, transcontamination has an effect on process change during the baking process, which the current conductivity ranges from 0.000267 until 0.0056 second per meter. Second per meter. Current intensity ranks from 1,54 until 3,20 ampere, and electrical power ranges from 139,00 until 287,10 joule per second. Transcontaminase with its capability in catalyzing cross-link reaction is able to alter the rheological properties and gluten-free bread butter. Rheological properties of gluten-free bread butter. The process parameter can be used as a reference in designing other baking ohmic based instrument for other gluten-free bread baking. Thank you.